Testing of normality of a certain set of data is very important as we are going to identify the correct statistical analysis that will be used in order for us to answer a certain problem or concern on the given set of data. Our set of data here, specifically on the second column, corresponds to the scores of a student. And if we are going to check whether this has significant difference with a certain test value, then we need to check first whether this is normally distributed or not. Because if we can guarantee that this set of data is normally distributed, then we can safely use the one sample t-test, as one of the assumptions for one sample t-test is that the set of data should be normally distributed. However, if it's not, then we are going to use the equivalent non-parametric test of one sample t-test, which is the Wilcoxon sign rank test. Again, we are going to check for the normality of distribution because a lot of statistical analyses are based on that assumption. In this here, we have the first two columns, or the two columns here. The first column is about the student number, or just the representation of our student. And again, the second column would correspond to their scores. In this variable view here, just a quick visit here. This is for our first column, and I just simply label nominal for our level of measurement because the numbers there are just representations of the student. And for our scores, I label it periodical exam scores. Okay, periodical exam scores, and the scale, the level of measurement is scale because that is on scores. Now, let's move back to our data view. Okay, there are actually a lot of statistical tests that will tell us the normality of distribution. There are also plots or graphical representations, we could do that. But for here, let us use the Shapiro-Wilk test for normality. Now, there are two common. We have Shapiro-Wilk's and then the Kolmogorov-Smirnov. But between the two of them, the Shapiro-Wilk's is oftentimes used for a small sample size. We have here 90 students. So we are going to use the Shapiro-Wilk's because the Kolmogorov-Smirnov is good for large quantities. Now, there are some references that will allow us to use what they call this one, Shapiro-Wilk for less than 50, less than 100, or even less than 200. But again, it could work on even until 300. There are also some references that will tell us even 2,000 will do. But again, for this time, we only have 90. Before we analyze whether this set of data is normal, let's consider these two hypotheses. The first hypothesis is the null hypothesis. We have here the set of data is not significantly different from a normal distribution. This means that if we fail to reject this, our set of data here is closely similar to a normal distribution. However, if we reject this null hypothesis, we have this alternative hypothesis telling us that the set of data is significantly different from a normal distribution. We can reject our null hypothesis if we could get a p-value or significance value of less than 0.05. By rejecting the null hypothesis, we can say that our data is not normally distributed. But of course, for some of us researchers, we would like to use parametric tests. We would like to assume normality of our distribution. That would mean we can only use one sample t-test if we fail to reject our null hypothesis. That means if we could get significance value or p-value greater than 0.05, we fail to reject our null hypothesis, and that would mean our data is closely similar to a normal distribution. Now here comes the calculation. Let us consider these menu buttons here, specifically an analyze. You click analyze, you go to descriptive statistics, you hover to that, and you will go to explore here. Once you click that, you will have a dialog box. Again, analyze, descriptive statistics, explore, click that one, and you have this here. What we just need to do is to click the column or the data which represents the scale data that we are going to check, and place it on dependent list by clicking this button. Okay. Now after that, you simply go to plots here. Okay, click the plots, uncheck stem and leaf. You can check histogram if you would like to, but since we are automatically moving on a Shapiro-Wilk, let's just simply click normality plots with tests. Once you check that, of course, you could check histogram and have another analysis for that, or helpful analysis or supporting analysis. But in this case, let's just simply click normality plots with test and say continue. Okay. Of course, you could go to statistics here, and since descriptives are checked, and make sure that by default, this is our confidence interval, 95%. Hence, again, as mentioned earlier, our significance value is 0.05. And of course, you have here your options as well. But just for plots alone and checking for normality test, continue. You click OK, and you will have this result. Okay. There are a lot of tables here. You can even see some graphs here for other graphical representation of our test for normality. But you can just simply move here, this test for normality data. Again, we have two, Kolmogorov, Smirnov, and the Shapiro-Wilk. But since our data is small, we have 90, n is equal to 90, let's proceed to Shapiro-Wilk. Consider the significance value here. The significance value is 0.105, or also known as 0.105. This is a significance value for a test for normality. And as you can see, this is greater than 0.05, which is our significance value. What does this tell us now? This significance value tells us that we fail to reject our null hypothesis because this is greater than 0.05. And if we fail to reject our null hypothesis, that would mean that our set of data identified earlier, this exam scores, is just closely similar to a normally distributed set of data. It's not significantly different from a normal distribution. With this in mind, we can now say that the test that we are going to use, if we are going to test for significance of this, with a test value, because we only have one sample here, is the parametric test one sample t test. That is the use of testing for normality, because if this is less than 0.05, then we're going to use the equivalent non-parametric test of one sample t test. So with this, again, we fail to reject the null hypothesis and say that our data here, the periodical exam scores, is closely related, or closely similar, or not significantly different from a normal distribution. See you in the next video.